Lesson 30, arithmetic sequences. So, first off, we're going to go through what arithmetic sequences are. I put this in quotations because the next part of this is part 1. That's going to be dealing with arithmetic sequences. Part 2 is going to be dealing with arithmetic series. So that's why I put those in brackets there. So first off, what is it? So it's going to be, I'm just going to write it down here, so follow along with me. A sequence in which the difference between consecutive terms is constant. Okay, so what does that mean? Well, something like this. So if we had 2 comma 5 comma 8 comma 11 comma 14 and then dot dot dot. So you can see that the difference between them is going to be 3 all the way up, right? So we've got plus 3 and then all the way up. And this dot 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 just means that it's going to go on forever too, right? This could also go in the negative direction though too. So we could start out with like 20 and then 18, 16, 14, 12, dot dot dot. So it can go down to, in that case it would just be minus 2 and then minus 2, minus 2. So that's pretty much what we're talking about with this, right? So we have a formula for this, though. It's on your formula sheet. So that's going to be the very first one on your formula sheet there. So just keep track of that. Okay, so here it is. And let's just go through what these things mean now. So T1, so maybe I'll just do this to kind of show us a below here. T1, that's going to be the first term. So that's going to be this, right? So the first term in our sequence would be 20 in that one. It would be 2 in that one. So that's what number would go in there. T here stands for term, by the way, too. So just as a way to remember that. Okay, and then N stands for the number of the term. So what I mean by that is like this would be the first, this would be the second, third, fourth, fifth. So that's all we mean, right? So that's what the N would stand for. Now T to the N, or T postscript N, that's going to be the value of the term at that number. So value of term at N. So whatever term you're talking about. And then lastly, D, this is going to stand for common difference. Okay, and now what's the point of this? So what the point is that we can use this formula that we're looking at here with these things, and we can look at something like this, and we can figure out a general term. So it's kind of like a own little formula for this sequence. And we can figure out, what the 50th term is, what we're going to do in a minute, but we can figure out the millionth term from that little formula if we wanted to. So we're going to use this to make up a formula for this. This is generally how this works. So part A of this says write the general term for the sequence here. So what we're going to do first, let's figure out what these things are. So T1, that's the first term, right? So that's going to be 2. N, Well, number of terms. So our formula that we're going to have is going to have an n because we could put anything we want in there. So we don't want to put anything in that for that. Tn as well, we're not going to want anything. But common difference, that's the one that's going to be important to us. What is the common difference between these? So I can see that these go up by 3 every time, right? So that's our common difference, positive 3. So d is equal to 3. So now that we know that, we can use our formula. Maybe I'll just write it down here again. Tn is equal to T1. Okay, so now let's just fill stuff in. So Tn, we're going to leave like that because we want to leave it like that. T1 is going to be equal to 2 plus, I'm going to leave this as n minus 1 for now, but then d is equal to 3. We need to expand this expression, so the 3 is going to be multiplied by both of those. So we'd have Tn is equal to 2 plus 3n minus 3. So our final expression for this is going to be Tn is equal to 3n minus 1. Just collected those like terms. So that's it. That's a general term for that sequence. Okay, so let's call that part A. Part B we'll do down here. So now part B, it says determine what the 50th, that's an n value, right? 50th term would be. So n is going to be equal to 50. All we got to do is use our formula now, that formula that's unique to this set of data, and just put 50 in place of n. And then that's going to tell us what that term will be. So we can say t, and then instead of n, we're going to write t and then 50 down there to show that we're talking about term 50 is equal to, and instead of 3 times n, I'm going to go 3 times 50 because that's what the term is. Now minus 1, so 3 times 50 is 150, minus 1, so 149. So t 50, we would say, is 149. Okay, this one, we're going to say T1 is equal to 7. That's the first term. D goes up by 5 every time. And yeah, that's all we need for now. So let's fill in. I'm not going to write the formula again. I'm just going to fill in the stuff we know. So we'd say Tn is equal to, T1 is 7, plus n minus 1 times d is 5. Tn is going to be 7 plus 5n minus 5. So our formula is going to be Tn is equal to 5n plus 2. Okay, part B, we'd say t at 50, it was terrible t, is equal to 5 times 50 plus 2. So t at 50, it's going to be, well, 5 times 50 is 250 plus 2, 252. Okay, last one. So for part A of, I'll make it blue. Part A of this, we'd say T1 was equal to 10. D, now here's the part that you could make a mistake because you can see, well, there's 4 difference between all of these, but it's going to be negative 4 because it's going down every time. So negative 4, negative 4, negative 4. All right, so now we'll just plug stuff in again. So Tn is equal to 10 plus n minus 1 times negative 4. Just notice that. Yeah, here I'll put bracket there so we know to multiply and not to subtract. Okay, and then we're going to go t to the n, or Tn, is equal to 10 plus, so negative 4n, plus 4. So up front here, I can kind of just rewrite this though as minus 4 because it was plus negative 4. So that's what we got so far. So Tn is going to be equal to negative 4 and then n plus 14. Okay, so t to the 50 is going to be negative 4 times 50 plus 14. It's going to be negative 186, which makes sense too, right? Because we're going more and more down, right? So you'd have a really big negative number. So yeah, so there you go. And I'll do that one too. All right, so that's the general idea of that first formula and how it works. So part one of this is just going to be really using this formula. So once we get to this point, looking for either, like what we were doing there, T50 or some other number, or the question might say, what is this n value? And that's what we're going to come up with here. So given this pattern, how many terms into the sequence before you get to the number 119? So how many terms into the sequence? That's talking about an n value. So what's n? All right. So let's start off with our formula. Tn is equal to T1 plus n minus 1 times d. And fill in what we know. So we know the first term is going to be 3. We know that d is going to be, well, the difference between these is 4, right? 3 plus 4 is 7. 7 plus 4 is 11. So we know that. So if we fill this in, we go Tn is equal to 3 plus n minus 1 times 4. And then if you expand that and simplify, you get 4n, that'd be minus 1. So 4n minus 1. So now we know one more thing here, right? This number 19. What is that? Well, it's saying how many terms go by, what's the n value when you get to 119. So what we need to do now is just replace 119. That's our Tn. That's our Tn value. So let's put in 119 is equal to 4n minus 1. Now it's just algebra. So we can just rearrange. I'm going to add 1 to both sides. So I got 120 is equal to 4n. Divide by 4. Divide by 4. So we get, kind of running out of room here, n is equal to 30. So we would go through 30 of these terms, right? They'd be like, 1, 2, 3, 4, all the way up to 30 before we got to this number. Okay. All right, so I'm going to get you guys to do this one on your own in a minute, and then I'll just kind of pop the answer up at you so you can look through it. So go ahead and pause the video now. Okay, if you didn't get that one, here's the answer for that. Look through to see if you got that. Because I had T1 was 12, and I had D was 7 in between those, right? So it would simplify to that. What will the person get paid for the last 6 hours of work? Okay, so there's that one. Just kind of look through to see if your answers match up with mine. This last one here, this might be a poorly worded question now that I'm kind of looking at it now. It says, what will the person get paid for the last 6 hours of work? Probably get paid on the sixth hour of work. So what would their money be is kind of what I was going with that. This would be more complicated if you were going to figure out how much they got paid for 6 hours of work. Because you have to do that for everyone and add them together. That's kind of where we're going to. But for now, let's just do this as if, like, what'd you get paid if n was equal to 6 is what we're saying. All right, so we just use our formula and say T6 is equal to 7 times 6 plus 5. So it'd be $47. Okay, moving on. You know what? I'm going to make part 2 in a separate video, though, so I'm going to end that one there.